In this video, we apply the empirical rule to answer questions about bell-shaped distributions. A bell-shaped distribution is a distribution that is unimodal and symmetric. For example, any distribution having this shape, you can see that it has one peak and it's approximately symmetric on both sides of that peak. All right, now this one would not be unimodal or symmetric. So this is not symmetric. And this one, this curve here is not unimodal. All right, so only this curve here is bell-shaped or unimodal and symmetric, right? Now, when you have a unimodal and symmetric curve or distribution, approximately 68% of the observations lie between one standard deviation of the mean. Approximately 95% of the observations lie between two standard deviations of the mean. And approximately 99.7% of the observations lie between three standard deviations of the mean. All right, and what does this mean? Let's make a picture of this statement. So here we got our bell-shaped curve, and what they're saying, and this is all of the distribution. In other words, these are all of the observations made. And so you can see that in the middle here, like this X bar here represents the mean, and S represents the standard deviation. So within one standard deviation, that is this region here, about 68% of the observations lie here in this region within one standard deviation from the mean. And about 95% of the observations lie in this region that is within two standard deviations of the mean. And about 99.7% of observations lie in this region here, which is within three standard deviations of the mean. All right, this is what the empirical rule says. All right, now let's look further at this situation. So again, this distribution gives 100% of the observations. So if you broke down 68%, if you broke down each region here, and tried to figure out the percentages of each of these regions here, we can do that because of the empirical rule. So that within one standard deviation of the mean, we see that there's 34% on this side and 34% on this side. And because within two standard deviations of the mean, there was 95% of the observations lie, 13.5% must be here, and 13.5% must be here. And the fact that 99.7 of observations lie within 3 standard deviations of the mean, it means that this region here must be 2.35%, and this region must be 2.35%, and this must be there 0.15 and this 0.15. Altogether, then, this is 100% of the observations. All right, now let's look at a few practice problems. This is critical information that we need when we answer questions related to the empirical rule. All right, now let's look at this practice problem here. Suppose 100 students' homework averages have a unimodal and symmetric distribution with a mean 60 and a standard deviation 4. Right, this is a typical type of question. They give you a unimodal and symmetric distribution. They may give you the mean and standard deviation, and they ask you different questions about that. So because the distribution is unimodal and symmetric, it means that we can apply the empirical rule. All right, so let's go ahead and do that. And we also know that the mean is 60 and the standard deviation is 4. So the very first step in solving this problem is to first apply the empirical rule. So what we're going to do is go ahead and make a bell-shaped curve. So I've made it here, bell-shaped curve, and S represents the standard deviation, X bar represents the mean. And our thing is we got to fill in all of these values here. So we got to know what is X bar plus S, 1S, what is X bar plus 2S, and so on. Right? So the way to do that is we're going to go ahead and just pull out the calculator to go really fast. Let's see. So we're going to do now X bar plus 1S means I'm adding 60, which is X bar, to S. So that's just going to give us 64. And then let's figure out what is X bar plus 2S. Well, 2 times S is 8, right? Because S is 4. And then, so 8 plus 60, which is the value of X bar, that's going to give us 68. And now 3S. Now 3S is really like saying 3 times 4. 3 times 4 is 12, and then 60. So this value here is 72. And then let's find these other values. X bar minus S, that is 56. And 2 times S, which is 8, minus 60, that is 52. And 3 times S is 12 minus 60. That is going to give us 48. All right, now that we've applied the empirical formula or the empirical rule to find these quantities, we should now be able to answer all of these questions. So let's go back up to the first. What percentage of homework grade averages are between 56 and 64? What percentage of homework grade averages are between 56 and 64? Well, this distribution represents the grade averages, suppose. and the homework grade averages. And between 56 and 64, that is this region here within 1 standard deviation of the mean. See, here's 56, 64. So what is the region in between those two values? That is 34 plus 34, which is 68. So we can say 68. All right, number 2, what percentage of homework grade averages are between 52 and 68? What percentage of homework grade averages are between 52 and 68? 52 and 68. Okay, 52 to 68. All right, that is 95%. Number 3, what percentage of homework grade averages are between 48 and 72? What percentages of homework grade averages are between 48 and 72? 48, 72, that is 3 standard deviations away from the mean. So that is this region right here, which is 99.7 based on the empirical rule. All right, next, what percentage of homework grade averages are between 56 and 60? 56 and 60 is this region here. So you can see that's 34%. Number 5, what percentage of homework grade averages are less than 60? So going back to our distribution here, less than 60. Okay, less than 60. So they want all of this here, region. And since we know this entire distribution represents 100% of the observations, we know this side here must be 50. So we can say 50%. Number 6, what percentage of homework grade averages are greater than 68? Go to our chart. Here's greater than 68. So that's this point 2.35 and plus 1.15. So that is going to give us 2.5. All right, so you can see how we applied the empirical rule to find or answer these questions. All right, it was very important to make this break up all of these percentages and find these quantities. All right, let's look at it. One more example. This time they ask us, a normal distribution of the song lengths of 150 songs has mean 232.9 seconds and standard deviation 49.5 seconds. Right? And what percentage of songs have lengths between 133.9 seconds and 33 331.9 seconds, and so on. All right, so again, we are given a normal distribution, which is another way of saying a bell-shaped curve, which is another way of saying a unimodal and symmetric distribution. All right, so the first thing we need to do is go ahead and make or find those quantities by applying the empirical rule. So the mean 232, standard deviation 49.5. Let's go ahead and graph here. Now I've started it here. So now we just need to compute these other quantities. And let's go ahead and pull out the calculator on this one, since they have a lot of decimals, and to make things go a little faster. So we're going to do 232.9 plus 49.5, so 282.4. And 232.9 plus 2 times 49.5 is giving us 331.9. And one more. 232.9 plus 3 times 49.5. This is giving us 381.4. All right, and then let's find these other values. That is 232.9 minus 49.5, which is 183.4. To 32.9 minus 2 times 49.5, 133.9. To 32.9 minus 3 times 49.5, 84.4. All right, so now that we've got all of our quantity values given here, we got the percentage breakdown for each region. We should now be able to answer all of the questions. All right. So what percentage of songs have lengths between 133.9 seconds and 331.9 seconds? 133.9 and 331. Okay. We see that 133.9 and 331, that looks like it is 95%. 95%. Two, what percentage of songs have lengths less than 183.4 seconds or greater than 282.4 seconds? So less than 183, that's all it is, and or greater than 282. That's all of this region. So they're talking about all of this region or all of this region. All right, so you can see in the middle there is 68%. So now we want the rest. Apart from the 68%, we want all of this and we want all of this. So if we do, and we know that the entire distribution represents 100%. So if we do 100 minus 68, you see that that is 32. Percent. Right. Next, they ask us how many standard deviations. All right. This question is a little different. And these others were asked the percentage. Here we're asked how many standard deviations apart are the song lengths 133.9 second and 331.9 second. How many standard deviations between those two values? One 133.9 and 331. 331, so you can see we go 1 standard deviation, 2 standard deviations, 3 standard deviations, 4 standard deviations. So it looks like 4 standard deviations apart. How many standard deviations apart are the song lengths 232.9 and 331.9? How many standard deviations apart are the song lengths 232.9 and 331.9? 232.9 and 331.9. So you can see we go 1 standard deviation, 2 standard deviations. So the answer is 2 standard deviations. Last question. Approximate the number of songs having lengths between 183.4 seconds and 282.4 seconds. Approximate the number of songs. All right. Now altogether, there were how many songs? We're going to need to know that. Altogether, there were 150 songs. So we want to know, out of those 150 songs, approximately how many songs were between 183.4 seconds and 282.4 seconds. So we want to know how many of those 150 songs lied within 68% of the mean. So the answer to this question is to multiply 150 songs times 68%. And we have to change 68% to a decimal first. And then when you multiply this, you're going to get 102. Approximately 102 songs. All right, I hope you found this video to be helpful. This was part of the math of numbers and symbols, but we feel that math is order in the broadest sense. Together, let's end disorder.